This video covers the design of the central core structure of the new BattleBot. So about 3 weeks ago, I came to the conclusion that I'm not going to have 4 omnidirectional wheels. Imperfections in my frame, imperfections in the floor, different loadings due to acceleration or deceleration means that only 3 wheels are going to be touching anyway, and which wheels are touching is unknown in advance. Therefore, I decided I'm going to control what touches. I'm going to go with a 3-wheel drive system. Therefore, the wheels placed 120 degrees apart are going to give me much better knowledge about the loading between the wheels and the floor. That allows me to go to a hex design in the core frame. Now, stop me if you've heard this before, but I just happen to have about 30 feet of 1¼ by 1¼ by 120 wall tubing. So that's what I'm going to build this out of. The hex is better strength-wise than a square. It's not as good as a circle, but compared to a circle, there's nice flat places to bolt things onto on a hex. When you look at this hex, obviously I'm looking at removing material, top and bottom. Material is not necessary or is not going to remove a lot of strength. The reason it's there is not for lightweight. It's there because I would like to run wiring through the hexes. Hexes, you say? I only see one hex. All right. All right, start with a pair of hexes. The top hex I would like to run power wiring through. The bottom hex I'd like to run signal wiring through. Now, to join these hexes, you need shear plates. Wherever possible, I'm always going to use structure for multiple uses. This shear plate houses a pair of wire rope isolators and tabs. When you look at the 3 of them, there are 6 tabs there where you can bolt a frame. That frame will be isolated from the core structure. I believe I'm going to mount batteries on that frame. I'm a bit worried. I see people burst into flames when they take big shocks. I know that lithium polymer or lithium ion batteries have the tendency to do that. So with isolators there, I should be able to reduce the shock the batteries feel. Next, I got to grow out to locations where I'm going to mount the wheels and the weapons. Once again, made out of 1¼ by 1¼ 120 wall tubing. And now add end caps for vertical strength, and of course I have to add shear panels. This shear panel does double duty. It's where I would mount my VESC speed controller. The 3 holes are for the 3-phase wires, and the slot is for communication and the sensor. All right, now we have a frame that is fairly strong in vertical loading and vertical shear, but obviously the outside elements need to be tied together for strength. there's a lower panel. This is going to be very lightweight. It's going to tie these three pieces together. This bay here is slightly larger than this bay. This bay is for the wheel mount. It turns out that I couldn't quite make them symmetric. The wheels are just a tad bit too big, but that's okay. And so there's a lower reinforcing structure and an upper reinforcing structure along with the appropriate mounts for the wheel. The wheels now are going to be mounted via 5 bolts, and they are, I'm hoping that they will shear, these bolts will shear if the wheels get a massive impact. That would essentially allow the entire pod to come off, and I would much rather have that happen than have the entire frame get tweaked, get bent or broken. All right, so now we have all the wheel areas are reinforced top and bottom. The weapons mounts, I'm going to show one weapon mount plate. It looks like these are just a random set of bolts, of bolt holes, but in reality, the top and bottom are regular intervals, standard intervals, and all these other irregular holes are matched to the wire rope isolators, the large wire rope isolators that I have. So if I'm going to mount a weapon via wire rope isolator, the holes will already be there. Now I'm going to turn this off because I have some other things to show on the inside. Primarily wiring and control. In this protected volume behind the weapon mount plate is the primary computer. It's actually a set of computers. There are 5 boards, Gen 1 anyway. There are 5 boards, and there's a main computer, which is the master, and 3 slave computers. They communicate through CAN bus. The main computer handles the communication with the base station, redundancy, and the 3 other computers each handle the steering at the individual OmniDrive pods. I needed fast computers, reasonably fast computers, to run the steering. I'm trying to do some algorithms that are fairly computationally intensive, and I don't want to be limited by the computer that I have. These are PIC 32, 120 megahertz, 32-bit, and they have full floating point hardware acceleration. Oh, look, it's a Team Waiachi switch. Those are not that unusual. In this protected bay, I have distribution blocks. This is the ground distribution block. This is the hot distribution block, the plus distribution block. And the idea on this one is that these little squares here house fuses. Each line that comes out of here is independently fused. These fuses in particular work in a way that I believe will be okay. Like a 100 amp fuse will take 200 amps for like a full minute. So they're not going to pop just because there's a little bit of an overload. However, if there's a short and they're drawing 350 amps, they will pop immediately. And the idea is to, if there's something that shorts a major power line, you want to disconnect it from your power source before you overload your batteries or cause your whole system to go down. I don't believe anybody I've ever heard currently uses fuses, probably for good reason, but it's one of the things I want to try out. On all of these wiring related items, I make tops. I have an idea. I'm not sure how well it's going to turn out. I imagine it'll go through iterations. This is a 3D printed part which sits on the backside of a VESC, the plate that holds the VESC, and the wires coming out of the VESC run through these various spots, and when you bolt a top plate over this, it's going to keep the connectors together in case a large shock. Now, you plug some connectors together and you think, man, those are really hard to get together, that'll never come apart. Under a 10G load, they fly apart. So this is supposed to hold them together. It also houses a little spot here for the the Bluetooth wireless 2.4 gigahertz transmitter, and that allows this transmitter to transmit right into the wheel. All right, so let's bring back the one weapon mount platform and the other two. And then a notional battery. The top just shows on the top here, there's a pair of batteries. These are 6S batteries. This is as large as I would put in there. The ones I will use will probably be smaller. They sit in this frame, and the frame bolts to the isolators. On the bottom, I show there are these machined covers that bolt through to the frame, and they restrain the batteries. The idea is I want to have a battery pack that is completely separable, right? So you would be able to unbolt this in these 6 locations and remove the entire battery pack and take it out for charging or maintenance, and then drop another pack in. Finally, plates. Likely I will have these water jet or laser jet out. Locally, I know people who will do that. And I'm going to have a number of different thicknesses, from maybe 50 thousandths all the way up to 3/16 or 1/4 inch. And the idea is that if I'm facing somebody who really doesn't have any form of top attack, I will put the lightweight plates top and bottom. If I am facing somebody who has a heavy top attack, I can put the heavier plates in and potentially even stack multiple plates if I need a lot of top armor. That's the center hex, and we're getting ready to go into manufacturing soon.